In this video, I'll be going over some of the homework problems for the Chapter 7 review that covers days 1 through 7. In this review guide, we have all of the problems kind of mixed around here from the different sections, and specifically problems like 1 through 10 here have problems from day 2 and problems from day 7. So just as a quick reminder, problems from day 2 is when we try to get bases to be the same. So for problem number 2, I might change both of those to a base of 2. So for 1/2, that's 2 to the negative first. And for 64, that's 2 to the 6. So then I would get negative 3x is equal to 6, and x is equal to negative 2. So it works out really nice when I can get bases to be the same. But if I take that idea and go down to number 5, 3 and 4, I really can't get bases to be the same there. So when I run into that issue, I take the log on both sides, and I am going to then use the product property of logs to move, the power property of logs to move the power out front. And then that's why I use the logs. And then I'm going to divide by the 2 and the log of 3. And you'll want to make sure to put that in your calculator. And when you do, to use parentheses around the denominator, just like I have it written here. And so just real fast, let's see here. Log of 4, parentheses, divided by parentheses 2 log 3. Double close that, and you get 0.631. And there it is. So a lot of times, though, you might have extra steps on top of that. So like number 6, you need to divide by 3 first. And so I have 6 to the x power equals 7. Then you're going to take the log on both sides. For number 7, you would subtract the 4 first. And then divide by 2. And specifically on this problem, you have a base of e. So while in number 6, I would take the log on both sides, just like I did for number 5. Number 7, I would suggest using the natural log on both sides so that things cancel a little bit easier. Because now that I move this power out front, the one thing that I'm not going to write here is the natural log of e, because that's just 1. So if you type the natural log of 6 into your calculator, which is 1.792, and then to finish this problem, you would add 1 and divide by 3. So if I add 1 and divide by 3, I get 0.931. So I have some different work there just because the base is e. Up here, I would just follow suit with number 5. And there's more there. So like number 8 might have an additional step to combine those logs together, but I'll let you try that on your own. The other thing that you might see is if there's already logs in the problem. So I'll work out number 9 and number 10 here. Notice the log is the same on both sides for problem number 9. So I would say 7x plus 1 equals x minus 2, and I would solve that for x. Now the hard part is I get a fraction, but it's also negative. And if you put that back in here, negative 1/2 minus 2 is a negative number. I can't take the log of a negative number. It's not possible. So even though I got an answer, it's no solution. So whenever you're solving an equation that involves logs, you do need to check your answer. For number 10, this is more of a conversion, so this is a much better example. And then I'll look at one more as well. So we have 8 as the base. The power is 1/3. Set that equal to 2x minus 1. Now we know 1/3 means cube root, and the cube root of 8 is 2. And so I get the following problem where x is like 3/2. And then if you plug 3/2 in here, is that okay? So 2 times 3/2 is 3. 3 minus 1 is 2. So we're in good shape. So number 12 would follow suit, but notice here it's the natural log, so your base would be e. And then you'll type in e to the 8th into your calculator. It's going to be a decimal. It's going to be a pretty large decimal. It is 2980.958. And then you set that equal to 2m plus 3, and then you just subtract 3, divide by 2. I'll let you finish that one there. But the part that gets people here is a lot of times people do a good job of converting it on number 10 because they see that 8. That 8 is clearly the base, but sometimes people forget that in number 12 when it's natural log, the base is e. 13, 14, 15, and 16 are the investment problems. Go back and look at day 3 if you have any questions about those, or reach out to me. But I want to specifically look at some of the ones on the back page or so here. So to evaluate a log, I'll do 23 and 24. Similar to what we just did with some of the equations, I'm going to convert it. So I'm going to take the base, x is the power, and I want to know what power changes it to the 4th root of 4. So we have 2 to the x power is equal to 4 would be 2 squared, and the power would be 1/4, and then that cleans up. 2 times a 4th is a half, so then x is a half. And problem 24, same thing. What power on 3 gives you 1/27? 27 is 3 to the 3rd, but then it would be -3 because I have a fraction that needs to be converted as a negative exponent. So that's a quick review of logs. The last part here that I want to show you is at the very end of this review guide, problems 32 through 35, using given values of logs to maybe answer questions about logs that we can't do by hand. So number 33, I have the log base 5 of 1/4. I can't type that into my calculator. I can't do that by hand. So I'm going to rewrite 1/4 using these numbers up here. So one thing that I would say is division can be rewritten as subtraction. And 4 itself can be rewritten as 2 times 2, or 2 squared. And then what I'm going to do is I'm going to move that power out front right here. And then I'm going to substitute in any values that I know at this point. Now the log base 5 of 1 is 0 minus 2 times 0.431. So then I would subtract that and get an answer of negative 0.862. For problem number 34, similar idea. This time I'm going to move the power first, but that would be the log base 5 of 7 minus log base 5 of 5. You know, we know that log base 5 of 7 is 1.209, but the log base 5 of 5 is just 1. And so my answer here would be 0.418. So that's just a quick video here that covers some of these problems in detail. I didn't cover everything just because it's your job to look over this and then let me know if there's anything else or in addition that you would like to see worked out. Just let me know. I'd be more than happy to help you.